of the finals. I only know how to make eggs, Rice Krispies, and waffles.
Ever since I found out about molecular gastronomy, it's pretty much been my thing. All I think about 24/7 is molecularizing food in a gastronomic way. It's what I do. I'm a chef.
Welcome to the finals of Top Chef. Congratulations for making it this far. For tonight's challenge, you will have to make a recipe using a form of energy.
10 minutes? We only have 10 minutes?
We only have 10 minutes to make something.
Guess we better get going.
Your energy options include mechanical energy, thermal energy, nuclear energy, chemical energy, electromagnetic energy.
Hello everybody, welcome to Lab 1, Energy Transformations. It's our first lab of fourth quarter. Crazy, I know. And we're going to incorporate some food items in today's lesson as well. Okay, let's do a quick review. And if you remember, there's two main forms of energy, potential and kinetic. Remember, potential is stored energy that's ready to go, and kinetic energy is the energy of motion. Now, when we talk about energy, we also talk about something called energy transformation. Energy transformation is when energy is converted from one form to another. So what I'd like us to do before we get started is watch a Study Jams video on energy and matter and the two main kinds of energy or forms of energy, potential and kinetic. Let's watch.
And then when they made it out of the house, the guy...
Sam, watch it!
Yikes! Did I get you?
No, but be careful. Those hands of yours are a potential disaster.
Actually, they're more like a kinetic disaster.
Sam, what are you talking about?
Energy. Potential energy and kinetic energy, to be exact. It's science.
No, I'm pretty sure it's clumsiness.
Well, energy is the ability to move or cause change in matter, and there are all kinds of it.
I don't know, Sam.
Let me explain. The movement of my hands is kinetic energy, which is caused by movement. It's energy in use. When my hands hit the glass, the kinetic energy from my hands released the potential energy of the glass.
What's the difference between kinetic and potential energy?
Potential energy is the possible or stored energy something has. When an object isn't moving, like the glass, it's got potential energy. Things like how high up the glass is and how much mass the glass has can make its potential energy more or less powerful. Kinetic energy can release that potential energy.
So when you hit the glass, you turned its potential energy into kinetic energy.
Exactly. Potential and kinetic are the two types of energy, but energy comes in many different forms. Like sound, the energy of vibrations within matter. When the glass struck the floor, crack! It sent vibrations through the room and created sound.
Is sound kinetic energy?
Yup, sound is the movement of vibrations through matter, so it's kinetic. The music, the chatter of the other diners, even the clinkety-clank of the plates and silverware.
All sound.
Speaking of sound, know what sounds good? Food.
Hey, food gives you energy, right?
It does. There's thermal energy and chemical energy in a plate of food.
Really?
Yeah. Thermal energy is heat, and it's kinetic. It's the motion of atoms and molecules in matter. When we touch the food, the heat is transferred by conduction from the hot food to our fork and mouth. The steam is thermal energy being transferred by convection into the air.
That's a lot of kinetic energy.
Definitely. The food also stores chemical energy, potential energy in the chemical compounds that's waiting to be released. When we eat the food, our body burns it and releases the chemical energy stored in the food.
When you burn something, doesn't that create heat?
Yeah. When chemical energy is released, it turns into thermal energy. Cars work the same way. They burn fuel and turn it into thermal and mechanical energy in order to run.
Seems like some types of energy are connected.
All energy is connected. It just keeps moving from place to place. There are more types of energy that we haven't even talked about yet just in this room.
More?
Oh, yeah. Electrical energy, radiant energy,
Whoa, one at a time. I know electrical energy. That's what we use to run appliances and lights, right?
Yup. Electrical energy is the movement of electrons through the world. It can be transferred into both radiant and mechanical energy.
Is radiant energy like light?
Exactly. Radiant energy can be light from the sun or any other light source. And electrical energy is connected to mechanical energy too.
How?
Well, electric motors transfer the electric energy into mechanical energy. Mechanical energy is then used or stored in moving gears, axles, wheels, or other parts. It can be potential energy, waiting to be used, or kinetic energy when the parts are in motion.
Geez, Sam. Energy may just be the ability to move or cause change in matter, but it certainly takes a lot of different forms. Whether it's matter in motion, like kinetic energy, or potential energy stored, ready and waiting to be used, there's no escaping it. Energy is absolutely everywhere.
See? Told ya. And you thought, oh!
And now spaghetti sauce is everywhere too. Sam.
Sorry.
Sam, put the fork down.
Okay, welcome back, everybody. Another good example of energy in transition or transformation is a roller coaster. It provides the energy transformation showing the track, and of course it's going up to the top. We have the cart going up, and at the very top of the track, that is 100% potential energy. When the track goes, or I should say when the cart goes down the track, we move on to 100% kinetic energy. Let me rephrase that. It's not 100% there. Notice there's a little slice of that pie that's not blue. That is going to be another type of energy that has been transformed due to friction. And that's thermal energy or heat energy, which is lost. A little bit is lost there. But again, it's transformed into that type of energy. So it doesn't, it's not created or destroyed, it's just another kind of energy. So let's take a look at Wile E. Coyote, and notice that this is some really cool cartoon info on potential and kinetic energy. Let's watch. Welcome back, everybody. Notice we have Wile E. Coyote, who has a coiled spring, pushed, ready to go, watching for the roadrunner. Roadrunner whooshes by, lets go of the spring, and it goes from potential stored in the coil, which is elastic potential energy, and then out it goes into the kinetic, and hopefully that roadrunner gets caught. We know he does not, though. Let's take a look at this flow chart of forms of energy. So the main two forms, potential and kinetic, and then underneath we have the subforms, or the specific ones that can transform from one to another. Let's take a look. First off, we have mechanical energy on the side of kinetic energy. And you'll notice that this is the energy of motion, ready to go, but it's in terms of either springs, it could be in terms of gears, it could be in terms of movement, water, wind, sound. All of those are mechanical energy. Electrical energy, like the name implies, is a flow of electrons going through a wire, or it could be a coil, metal coil. It could also be lightning going through the air. Electromagnetic or radiant, light energy. Light energy is the energy of the movement of light waves, and please note that comes in the form of good old-fashioned light that we're using right now. It also comes in the form of radio waves, microwaves, and x-rays, ultraviolet and gamma. Heat or thermal energy is next. That's the energy of moving particles. The faster particles of an object are moving, bit more heat. And a nice example of that would be fire. Nuclear energy. Nuclear energy is going to be energy that's stored in an atom. Remember, this is potential energy because it's ready to be used, and it can be used in different kinds of nuclear reactions, whether it's a fission, where the atom is broken apart, or if it's a fusion reaction, where we have atoms coming together, and that actually happens in the sun. All right, and finally we have chemical energy. Chemical energy is stored in the bonds of objects, and please note we have so much chemical energy. We are made of chemical energy. We're using chemical energy when we're eating our food. Gasoline, wood, any type of fuel is chemical energy stored, ready to be used. So what I'm going to ask you to do is, on your sheet there is a 5-part series of energy forms and energy transformation. We're going to start with parts 1 and 2. Please go ahead and fill in 1 through 11 with the appropriate types of energy. And then in part 2, do the same thing, just filling in the sentences with what kind of energy is being transformed. And I will be posting those answers on Wednesday. Okay, let's take a peek at this interesting simulation, energy transformations. It's really an interesting way of looking at energy. Now please note, in a school setting we would be doing stations, moving from a certain type of energy, forming to another type of energy. But we're going to be using simulations to help us with that. So let's take a look at how that works. I'm going to give you a few examples on the computer. Okay?
Perfect.
Alright, so I'd like you to go ahead and work on part 3 of your worksheet with that simulation and fill it in 1 through 15. And then we're going to take a look at a sequencing. And this is more in a diagram form. So let's take a look at this example. Notice me start off with nuclear energy, which is again the energy in an atom. That is a fusion reaction, which is happening in the sun. The sun is going to transform that type of energy to radiant or light energy, electromagnetic. That energy is going to, in the process of photosynthesis, make the plants on Earth start growing and producing food for us. Notice there is a soccer ball player. Notice that that person ate some food, like maybe cornflakes from the corn. And that energy is transformed to chemical energy. Chemical energy is energy that is, again, in the bonds of our body, atoms, and ready to be used for, in this case, playing soccer, or also by using a hand-generated flashlight. That's a hand-generated flashlight, not to be confused with just one that is already battery powered. So the hand-generated flashlight is interesting because it can be used if you are in a situation where you have no batteries, which can happen, and all you do, you can look at this lovely picture here, parts of a hand-cranked or hand-generated flashlight. You have the crank, which is connected to the gears, which is going to power a generator, which is going to allow electricity to flow and thankfully cause the light to be emitting. So we have a number of transformations just in this one device. Okay, so now with all that information, I'm going to ask you to get some more in our energy transformation blend space. Go ahead and watch the tiles. There's some similar tiles that we've already looked at, including the energy transformation simulation, but just browse through those again. And once you're done with that, I'm going to ask you to write a paragraph using the word bank provided on the energy sequence here of what is happening from beginning to end in terms of energy transformation. Okay? Please note a key point, all energy on Earth is coming from our sun. If we did not have our sun, we would have no energy, because that is where we're going to get the electromagnetic energy to go into our food, where we're eating the food, where our body is able to process it, and we're able to do something with our hands, with our body, just continue that energy sequence. Please note that there is some energy stored in the earth, but again, all the energy is initially coming from the sun. All right, last but not least, we have another energy sequence simulation. This time, it's going to ask you to bring in some man-made ways of harnessing energy and using it, either to power a city, whether it be to, glean more information or energy from plants or animals that we can utilize on a day-to-day basis. So go ahead and complete that 1 through 5.
Check the highlighted answer and try again.
And then once you're done with that, you'll be finished with today's lesson. Please note that I am looking for this to be hopefully submitted as one PDF now that I'm able to go right through Kami into Google Classroom, and there should be no need to have to do any kind of pasting of a shareable link, if you will. So we should be clear and good to go with that. But do note that if you have any questions, definitely meet with the Google Meet at 11 in the morning, and any email time, of course. And as well, just note that if you are missing any work, do note that the time has come for all of information from good old quarter 3 to be put in. So if you have any missing work, I'm going to ask you to go ahead and do that. Before we close, I'd like you to just see a quick simulation for Mrs. McAllister here. I'm going to make myself a tasty strawberry smoothie. All right, almond milk, the milk of choice in the McAllister household. So right now, if you're thinking about what kind of energy we have currently, there's a few going on. We have the chemical energy stored in the strawberries and the milk. And we have the electrical energy that is going to be flowing from our electrical outlet into the blender. And then once I turn the blender on, we're going to have the gears and the blades turning, which is mechanical energy. So we have some really nice transformations here. Electrical energy with the wire, or the electricity, going into the blender, turning the blade, which is going to be, again, mechanical. This is going to be, again, all the food is chemical. And then once I drink it, that is going to be used in my body as chemical energy too. So let's get that started. Oh, it's just right. All right, let's try it out. A little chunky, but I think we're good. All right, this is chemical energy, and it's good. I hope you can make one for yourself, and have a great day. Bye-bye.